It's an absolute pleasure to be here. So if we want to build massive, gigantic simulations of virtual worlds or completely new ways of modeling cities or cells or economies, huge simulations that run on thousands of cores, it's a real challenge today. It's something that previously has only really been available to people with supercomputers. And it generally presents a very challenging programming model for developers. You've got to manage servers. You've got to cope with the synchronization of information. You've got to do so many things beyond just building your application. So at Improbable, we've built a distributed operating system we call SpatialOS that runs on Google Cloud and makes it possible to build these kinds of applications. Exactly the types of virtual worlds and massive simulations that we've all dreamed of, but put into the hands of developers so that it can be iterated on and built quickly and efficiently. And at the end of last year, we announced a massive innovation program with Google, which makes it almost completely free for hundreds of game studios to build completely new applications on top of SpatialOS. And though this first program was targeted at gaming, and it's only been a couple months, there's been an enormous number of really cool products produced, and I want to show you some examples of some of those. These include virtual worlds like Worlds Adrift that are 2,000 square kilometers in size, worlds with their own ecologies, worlds with massive numbers of players sharing the same space, no more sharding, no more separation. Experiences that in many cases have been built by teams of 3 or 5 developers, and our beta is live and active right now, and with the community, we're continually improving and adding to what SpatialOS can do for gaming. But today, I'm actually here to talk to you about the next step, the really big, significant, and important problems, which in one moment we will soon be able to talk about. Slide transition. There we go. So thinking about large-scale simulation as a way of solving problems, a good way to begin is to think about an example. Think about the most important decision that a company or a government makes, right? Let's take an example of what that could look like. Imagine thinking about how to change a massive cellular network that spans an entire city or a country. Any change you might think of making, whether it's a modification to the infrastructure, a change to a protocol, or an alteration in policy, is going to have millions of cascading effects, which are incredibly difficult to comprehend or think about. And the reason for this is that we're dealing really with emergent systems. And this is an idea I want to put across today. The idea that our world, the cells in your body, our economies, the big infrastructure that we build together, they all represent millions of complex emergent systems. And if we really want to understand these systems, we have to go a lot further than just using machine learning or past data. We need to learn to completely recreate these systems in their entirety. I mean, actually replicating entire cities on massive simulations, building models of these networks that have never been possible before. This is a gigantic and daunting technical challenge. It can't be solved through large-scale parallel systems. We need to build new kinds of semi-parallel distributed systems that can make this stuff work. And if we really want to change our world, we need developers like you to be able to run these systems in real time, build new businesses, and build new services that run on top of this stuff. And that's precisely what we've been doing with SpatialOS. And I'm pleased to announce that we're going to be open sourcing more and more content and showing more and more frameworks over the course of the next 6 months that are going to make it possible for more developers to attack new problem domains. And just like Google, with the spirit of open development and sharing content, we intend to do everything we can to foster a community where developers can share code, share frameworks, share integrations, and start to build and create new services and businesses. We don't all have to start from scratch. We can start to create an ecosystem to make this stuff possible. And that's why we've chosen to partner with Google. We truly believe that the cloud is not going to be a zero-sum game. The age of closed systems and trying to, in effect, hothouse developers into committing to a closed ecosystem are over. We can't succeed unless you succeed, and I think Google recognizes that. And that's the genuine reason why I'm here today and why we've chosen to make this partnership happen. We're also going to be announcing incredible new integrations with services, ranging from machine learning simulations that can be added into our tech to integrations with services like YouTube, which we'll be talking more about this year, that are going to make our technology even more functional and even more useful to you. So I've talked a lot about what's possible, but I haven't shown you anything really cool yet. So I want to show you something that we built in conjunction with the UK government. And it's been pretty secret until just basically this week, and I'm finally able to show it to you. This is the largest simulation of its kind ever created. This is a complete simulation of an entire UK city. Its telco network, its power grid, its transport network, its sewage systems, its housing demographics, even the way in which people move around and interact with the city. We're going to be open sourcing some of this content later this year. This runs on thousands of cores, and it's able to run in real time using Unity for visualization and interaction with the simulation. This has already started to transform the ways we look at cascading failure in emergent systems, change how we do infrastructure planning, change how we think about running services. And my contention to you today is that this is the future for how we're going to look at how all the systems in our world operate, not just looking at past data, but recreating them, rethinking how we can make these what-if decisions. There's even companies that are beginning to use spatial to run systems of autonomous vehicles, being able to manage them as fleets. So I want to leave you with an idea. This thing here, AI, Google talks about it all the time. You can't go on TechCrunch without seeing an AI article. But this idea, recreating reality, building reality-scale simulations and services is just as important, and I believe it's going to underpin how our world is going to transform, whether it's simulations of tumors in cells that can help us understand disease, or models of infrastructure that can help us save money and make better choices. So with your help and the ability to build an open community on our technology, we hope to kickstart this. If you're excited, please check out what we have online. You can download our SDK right now and get started making games. Thank you.